Okay, so let's go back to our original context, which I introduced last week, which is the production of the N95 mask. So far, what we looked at last week was the material sheet, which tells you that the actual filtering part of the mask is made from polypropylene, which is the common name of polypropylene. So polypropylene is the actual IUPAC nomenclature. Now, polypropylene is made from propene, and we're actually going to look at this process of making polypropylene on Wednesday. But for now, I can tell you that propene, and you should be able to draw propene, is an alkene with one carbon-carbon double bond. So this is propene. And the most common way to make propene is via propane. Um, Unfortunately, the reaction going from propane to propene is not part of the VC course. I'm not going to go into it because there are way too many reactions you have to memorize as it is. Not so much in year 11, more in year 12. But if you look at this, what you're doing is you're just getting rid of two hydrogen atoms and introduce a CC double bond into the molecule. So that is propane. So the question is, where does propane actually come from? Now, propane, if you want to use propane as your starting material, you're not going to probably be able to create it from anything. The most common way to get it is from crude oil, and you probably can say this for the majority of hydrocarbons that you may see as a starting material to make anything, with the exception of, I guess, methane, which you can get from biogas, but we'll talk about that next year. So propane actually, you actually get from crude oil. So this is probably a good opportunity to formally define crude oil. And you do need this for this topic, by the way, for anyone who wonders whether you need to know the definition of crude oil. So this is the carbon cycle. Anyone who has done the first two topics of the research assignment, especially the first one on biofuels, probably have read all about crude oil and everything, but I'm just going to repeat this for anyone who has forgotten. So you can start from plants, and I'm not going to bother with like combustion and things like that, but the plants can release CO2 via respiration and absorb it via photosynthesis, but essentially the carbon in the air is going to either go into the plant or goes out into the atmosphere. Animals eat plants. Oh my God, shocking. And anyway, when they both died, they will decompose into fossils, and after a long period of time under high pressure, the fossils will turn into fossil fuels. So there are three types of fossil fuels based on the state. The solid version is coal, the liquid is crude oil, and the gas version is natural gas. Okay, so a way to define crude oil is that it's the liquid form of fossil fuels that is formed from the remains of small marine plants and animals, and is trapped between layers of rocks. So this is another diagram of that. You just have little fish and stuff, and they died and they get trapped in the rocks, and then they turn into crude oil, which is essentially because most all living organism contain carbon, hydrogen, oxygen, and some other elements. So if you the decay of the organism over time, especially under high pressure, essentially you suck the water out of the fossil and you just end up with carbon and hydrogen in the end, which is essentially hydrocarbon. It is extracted. Crude oil is extracted by drilling through the layers of impermeable rocks, and you can get it from sea. We'll talk about maybe some of that. Actually, you mainly get it from sea, but sometimes you can get it from land as well. So that's an oil rig. So I guess we can bring this one step back and say the crude oil is essentially extracted from crude oil that is trapped under layers of rocks via a process of extraction. And I think this is as far back as we can go. This is definitely your starting point. You cannot go back any further unless you plan to make fossil fuel, but I don't think you will be there to get the product. Okay, so the trapped crude oil is going to be extracted to turn into crude oil. So what crude oil is, and I think I just briefly talked about it, it is actually a mixture of hydrocarbons. So living organism contains carbon, hydrogen, oxygen. You extract the water, so extract the oxygen. You should eventually end up with carbon and hydrogen. And if you wait long enough, you end up with just carbon, and that's coal. But what you need to do is you need to go from this mixture of hydrocarbon to now to propane, which is just one hydrocarbon. So you need to separate the different hydrocarbons from this mixture, and the process of doing that is called fractional distillation. So we're going to talk about that. This is probably a better definition of crude oil anyway. At least it tells you what the chemical composition is. So it is a mixture of hydrocarbons, mainly alkanes. Here are some examples. Alkanes of different sizes. So if you want to separate the alkanes to actually get propane, it needs to go through a process of fractional distillation. So this is an example of fractional distillation column. So it is a process of involving heating up the hydrocarbon mixtures, and the substances would vaporize at different temperatures depending on their sizes. And as they evaporate, they are separately recondensed. I think this is just the general process of distilling anything. You heat it up and then you recondense it. And fractional is because you distilling fractions of crude oil one at a time. All right, so I'm gonna put this handout somewhere so you can print it out if you want. You could draw it if you want. So let's just go through the column, the process of fractional distillation in a little bit more detail. So crude oil come in, and crude oil is going to get heated, and essentially the lightest hydrocarbon, the lightest alkane, the smallest alkane, the one with the least amount of carbon atoms, will be the first one that gets evaporated. So it's going to go through all of this and come out up here. It really depends on the temperature that you use for collection, but sometimes you actually get a smaller mixture of gases, alkane gas. So normally C1 to 4, but you could distill this further into C1, C2, C3, C4. By C1, C2, I mean CH4, C2H6, C3H8, and C4H10. So this will be used as your LPG. We look at LPG in year 12 as well. So your liquefied petroleum gas. So you can liquefy the gas using high pressure, and that's for cooking or heating. Okay, anything that's a little bit bigger than that is going to be recondensed. So essentially, the next wave of vapor that comes out is going to meet this cap, this bubble cap, and it's going to turn back into liquid, and then it gets collected. So you have your chemical industry step C5 to C7. So obviously, if we go back to our context, our propane is going to come from here. So you need to further extract propane. Propane is very useful. Ethane is the other very useful product. Okay, now let's say there's another wave of vapor coming out, and then it get recondensed again, and then it's going to come out around 250 degrees. So notice how there is an increase in the temperature, the boiling temperature of the substance. And this is the main reason why we do fractional distillation in the first place, because you want to get this product, which is petrol. Let's not do that. So petrol, and this is it's used mainly for fuel for transportation. C8H18 is probably the main component of petrol, so octane. And then you can have other products with a longer carbon chain like kerosene, so it's around C10 to C18, and then gas oil. So diesel is the other main fuel that anyone who has done the first topic of the research assignment on biofuels, they probably have come across diesel and biodiesel. And then there's the bit that you can't even vaporize because they're way too heavy and big with a very long carbon chain, and that's the residue. And normally this is your bitumen, so you use it to lie the road and things like that. It's probably still come out as liquid or solid depending on how big it is. So this is fractional distillation. It's essentially a process to separate the alkanes. In this case specifically, we're just going to focus on alkanes. Separate a mixture of alkanes based on their size. And the question, of course, is why, and that's actually the focus of the next video. So I'm just going to stop this one.